One backs of Giants today. This will be about the third time I've recorded this, and I got people coming in soon, so I gotta see if I can get through it. But this is I gotta change the marker out. This is how to get the bevel on a valley. I call them lay boards. I guess the kind of official term is sleeper. But how do you get the bevel? A lot of people will show you how to get the length of it and get all the miters and everything, but they don't really tell you how to get the bevel. And if they do, it'll be something in degrees that you gotta subtract half of the hip bevel and all that. I don't really do it that way. I use rise and run. I don't use degrees until I get all the way to put in the degree on the saw. I really would never do this. I've done it for small models that I was just messing around with myself, but I do it the old school way, where you pull the distance back after you plane in the 1.5 inches, and you pull your chalk line and all that. Pretty much everybody does that. But if you're curious, I enjoy learning about this kind of thing. So I'm gonna quickly draw a model. So you have your gable end over here. You got your ridge for your main roof, and then you'll have a dormer or something to that effect, a tie-in, a roof tie-in in here. There's my gable, and here's my valley, and then my other valley, like that. So we're looking at it. I gave you this to give that perspective of which way we're looking at it, but I don't want to focus on any of this. So we got to figure out two lengths to make a ratio in order to get that bevel. One of them is going to be from viewing this from the side. So we're rotating it. Here it will be counterclockwise, probably 20 degrees in order to get this view. So here would be the main roof, and then you have your ridge coming out, and that would be your common on the rake. But then if you plumb straight down, it'll be the rise. So what we need to do is we need to determine a good point to get a set distance for the way. Okay, let me reset my explanation. What we need is a leg of a triangle that's basically going to be squaring up from the roof, not plumbing, but squaring up. So if I put a framing square, it's not to scale. If I put a square on this roof and I go straight up like that, and I continue on, and then this ridge, I run this ridge theoretically straight out to this point. That's what we're aiming for. This distance right here. Call it X. That's what we want. Now you can determine it different ways anywhere along this point, but what you really need is you need the length this way in order to get it. And I think it's just easiest to go, because we already know what this length is, or at least we can easily calculate that. So all this is right here is just, whatever that is, a 7 pitch or whatever. You're just switching, you're taking the diagonal here, and now your diagonal is becoming your run, and now you just got to calculate the rise. That's pretty easy. Most guys that are into this stuff can do that. Fairly simple. If you want some information on how to do that, comments, and I'll be more than happy to do a video or walk through how that's done and my way of doing it. But we're gonna put this length into, we're gonna set that aside because we're gonna need it later. Okay, so now we got that. Now let's switch out of that for a moment and let's go up here back to this triangle. So this right here, connecting these, will be the span of the dormer. Now I'm just doing real chop down math. I'm not worrying about, you know, if you have a overhang or nothing like that. This is just basic triangles. All that stuff is much more technical to do, and I'd rather just keep it simple for the concept. But so let's draw this. We're coming from we're our eyes are plumbing down and looking straight down from here. So we're gonna have, this would be the span and the ridge and also the rake going from midpoint of the span up to where the ridge dies into the roof. Those are two different lengths. Even though they are in plan view, they are the same distance. On the rake, as you can see, if I go from here and I go up, I mean, it may take a second to kind of get through your head, but you've got, this is one, the ridge is one length, and then the rake length, the diagonal is another one. So that's what we got to understand with this. But essentially, what we're trying to do is this point where it runs into 90 degrees with this line. So it's a square from this line over to here, and that is what we need. Okay, so first thing you got to do, you need to do is determine, you got your whatever your distance is up the rake. And how do you get that? Well, we know our rise and we know our run, so we know the pitch of the roof, and that gives us ability to determine the diagonal here. So we need a diagonal measurement of that. Once we got the diagonal measurement, we got half of our span. That gives us the run of this side. Okay, so that I put diagonal, but this is actually going to be the run here for this particular triangle, and this is the rise. I think they write it with an RI like that. And then what we need to determine is the diagonal there. So a squared plus b squared equals c squared. That's really easy to get, by the way. You don't need construction calculators. It's so simple. You can get one that, if it has a square root button, it's such an easy process to get that on your regular phone or $5 calculator. It's not even funny. Okay, once we have all that information, what we need to do is we need to convert this bigger triangle right here, and we need to scale it down to this triangle here. But keep track of what information we need. We need to end up with the rise of this triangle. So how do we determine that? We need to, that means the only known length that we have is this distance, and that is the diagonal of the smaller triangle. So we have, the way I like to do it is this. I like diagonal on top, and then rise and run. And then I'm going to set something up over here. So if we have the big triangle, we need to we have the diagonal. That, you know, and this is a thing with this, with, you know, these type of processes for me, and really why I don't use them that much. It's easy to get thrown off, and a lot of times I gotta zoom back out and think, okay, what the heck am I doing right? What am I really trying to figure out? So, and this is like real time, you know, this is the way I do it. So I know the given information, I have all this information here for the big triangle. So now I need to convert it down. The only one that I have is this run is the diagonal of this other triangle. So if I have, all these are numbers up here, whatever they are, but I need to get the diagonal. This is the number I need up here, and I guess if I stare at it long enough. Diagonal, small triangle. So the run of the big triangle here ends up being the diagonal of this one. Okay, so if we're using numbers, let's